okay, it's now starting out. Like, okay, while we are doing this, we found the most important edge in terms of the importance is that it is mostly traveled, you know. So it's that kind of important. It's like you know, if it is a city and these are roads and these are locations, the nodes are locations. So this is an important road, like the Bosphorus Bridge we have. You know, it's important. What happens if we take it out? So we start to break it apart. I mean, if all of them are equally important, then maybe it wouldn't, you know, one of them is out. But of course, it depends, you know, if it is, it depends. For example, these are all, you know, okay, well, equally important. What happens if I take one out? Well, it's a big change. It's a big change, you know, it depends, of course. But think about a big network, many nodes, many links, and you're removing like the one between 2 and 3. Okay, who cares? I mean, it's the case. I mean, you don't mind if the municipality is digging some small street somewhere. You don't mind if you make a detour. This is not a problem. You know, but if I take 5 and 7, so all the people has to travel from 5 to 6 and from 6 to 7. So what happens is that it is getting those, it's getting more congested, right? So these roads will not take the capacity maybe. Because there is, municipality is doing some work between 5 and 7.
Shall I enlarge the roads if they are most frequently used one?
Shall I enlarge?
Because now the network is homogeneous, I like to put a remark over there that soon we're going to study also weighted networks. So I'm going to put some attributes in their mind. Yeah,
okay.
Just
Shall we talk about that?
I don't know, not now. I'm not suggesting that we should talk about now, but eventually we'll be talking about that.
Yeah. It is like,
for instance, if I'm an engineer and if I see this, I would say, rather if I make if there are the road networks, for instance,
yeah.
if I create the widths of all the roads are the same, then since 5 and 7 are going to be used mostly for a given period of time, and again the time is, you know, equally, you know, shared or whatever. Then, because everyone is going to need to travel through from one part to another by using the 5 and 7 link, then there will be a congestion. But if I, for instance,
make it larger,
increase the width, or somewhat increase the capacity of
local
capacity of 5, 7.
Let me say it this way. Let me tell it this way. Then, if all these roads are equal lanes, number of lanes, they're all equal number of lanes, then I can say that they're going to be, or let me say that I'm the mayor. I'm deciding which roads to be 2 lanes.
We definitely vote for you.
Yeah, thank you. Which roads will be 2 lanes? Which roads shall remain 1 lane? You know, we have some budget. We want to make some of the roads 2 lanes. So I would be, you know, definitely be making 5 and 7 2 lanes. If I have a little bit of money, that I can afford only 1 road to be 2 lanes, right?
So then you're suggesting that in order to be able to understand what road capacity is supposed to be enlarged or shortened, first we consider them to be homogeneous and do the network analysis, look at carrying capacity and decide accordingly.
Exactly. They are all equal 1 lane. I make it 2 lanes. If I have some more budget that I can make, you know, spend more money to be able to make more roads 2 lanes, I'm definitely not going to make 2 and 3 2 lanes, right? Because it is not really important. Even if I do it, even, you know, people who didn't make this calculation, is ignorant of that, but living in that city, will start to complain why you are making this road 2 lanes, because nobody is using it, they will say. But looking at this, I can say, okay, I have some more budget, or and then I will make 2, 5, 3, 5, 7, 9, and 7, 10 as well, maybe. You know, looking at the between the centralities for those, I can turn them into
Can I
two
ask
lanes.
one more question?
Yeah, please.
But so now, you, first of all, you exactly put the nodes over there, and you didn't put any weight or any attribute to the
No.
nodes. Suppose those nodes are the subclasses of the municipality, like SAMs,
Yeah,
and suppose the population of those SAMs are not equally distributed.
that's another problem. Yeah,
So
becoming a
then,
mayor is a difficult.
yes,
It doesn't end.
first you have to have a PhD in architecture.
Yeah.
Anyway, I mean, because now we seem to suggest a way that, first of all, create a homogeneous network, do the between the centrality analysis, then arrange the road capacities accordingly. But now, maybe starting with the homogeneous networks may not be a good idea because the nodes are not homogeneous as well.
Yeah.
Uh,
What are we gonna do?
But exactly. Very good question. Atakan, Ebru, Yoshi, I forgot your name.
I have.
Hayado, yeah.
What do you think? I mean,
What do you think? What shall we do? Because this thing is a damn good strategy. I said damn
No,
sorry
I think-
about that, but you know,
yeah, you should.
but if the populations are since
Can we say it in English? For do you speak Turkish? You know Japanese, of course. You know English. How is your Turkish?
Biraz.
Biraz.
oh,
Did you
and you say
did you understand?
It's a lot.
Did you understand what he was selling? No.
Even I don't. Just kidding.
So you should complain. I mean, you should be angry about that. What's going on? He was talking about you, actually. He was talking about you, so that's the reason. This is how I stopped him to make nasty comments about you. So you have to talk to him after the. All right.
But I initiated. No, just kidding.
So, tell me.
No, I mean, are you asking the question that
No,
first we shall put the nodes and the nodes sizes are not equal? Is it the question? What is the question?
Yeah,
Rephrase the
okay,
question.
oh my God. I repeat the question. So the problem is, well, we were getting a little bit quick over here,
Yeah, that's
but first of all,
I'm sorry.
we said what we introduced is an attribute for the edge. Of course, like for example, you would remember that when we were having those flight network, there were a capacity element in those flight networks, that how many times in a week we have a flight in between two nodes, that means two cities. And some of them, like, I don't know, maybe 50, 100, so there are so many flights between Istanbul and Ankara, or between Paris and Lyon. So we include an edge attribute, but when we were talking about, in this case, we talked about number of lanes, or the width of the road. Number of lanes is okay, probably. Number of lanes. How many number of lanes there are in those edges? Suppose that this is a city. This is an edge attribute. We're including an edge attribute. It is like, it could be, for example, for our bus network for Istanbul city, when we were doing that, we again looked at the capacity. In that case, we looked at how many number of times there are services. Because you know there are some, for example, we have 59R. Do you know 59R? Do you use bus or?
Yes, I do.
You know 59R, like in order to come here, you use 59R.
Sometimes.
Yeah, 59R is starting from one place and ending in another place, and you mark you know, every edge, every node that it is traveling to. And what you can add as an edge attribute is that how many times in a day we have a service. That means we start at 6, 6:40, you know, 7, 7:40, that we might be having this intervals and this number of services. And then what you can do, you look at the bus. How many people can fit into the bus? So I can have the capacity as the edge attribute over here. So if I add everything, all like 59R, we have, what do we have? 58. Do we have 58R? You know, we have a 43 something. 43R. We have many 59s not coming to here, but at least passing in front of Ak Merkez. If we add them all, we have a capacity, a big capacity. And why I'm talking about the bus size number, you know, the bus is important because if I map the whole Istanbul, I have to take into consideration the metro. The metro capacity per, you know, unit vehicle is much higher than the bus. Think about ferries, it's much bigger than that. Put that in. There is another important matter here, that is the cost of travel. Because it's different with a bus, and it is different with a ferry. Ferry is much more expensive. So you have to decide, you have to do some optimization using this and those values as well. And besides all of that, if I make this, you know, like the municipalities in Istanbul, and this is the map that I have, then it comes to the point that where, you know, then I have to think about the population of each municipality, because then some of these circles will be bigger, some of them will be tiny. So that's also important. Then you're not going to be making some of the, you know, if there's a tiny, small node connecting to another small node, although maybe it is, I don't know, you have to consider, you know, you have to think about how many times people will be traveling over here. So we have to think about that too. But these are all extra weights that will be coming into networks, but without any of these weights. Now let's move on without the weights. That, you know, we talked about it. I'm backing up. That was a side subject. I'm backing up. I'm taking a reverse. Now we're coming. There are no weights, no 2 lanes, no 1 lanes. It is only 1 lane all over the network. All right. So I say, I want to know if there are partitions in this network. Just like, you know, you have your Facebook network, you have your Twitter network. There are ways that you can obtain these information, like you can automatically, because think about Facebook. You have so many friends, and your friends have so many other friends, and or LinkedIn. In order for you to be, you know, doing that, sorry.
Can I ask a question?
Yeah, do you want me to show it?
Yeah.
Or no?
I'm just curious, how many different types of thicknesses are there in this network?
We looked at it.
Yeah. How many of
You're
them?
asking me or you're asking?
No, that's fine. So I have the thinnest one, and the thinnest ones are 2, 3, 2, 4, 3, 4, and exactly the symmetric of that, right? And what is the next thick one?
Let me see. This is
Yeah.
1, 2.
2. This is 3.
Ah, this is 3.
Yeah.
Do that. 14, 10, 10. 21. This is a perfect symmetry, I guess, right?
Of course it has to.
Good. So we can also create a thing like how many of them have 10, how many of them have blah, right? it is not the distribution that you showed us. It was packed. Now they are the links. And how many are? Maybe, yeah. I thought it was only 4, but now I'm mistaken because it's just by looking at the eye, I made a mistake. Okay.
Yeah, I can make it more visible if you like. That's also possible. But
Yeah, it's okay. I'm just sorry about that.
okay, so we were talking about how to break it apart. You know that we say okay, these are like two blobs. There are two sections in this network. I can say it's easy. This is only by looking I can say well there are two places. But when you think about your friendship network in Facebook, you cannot do it by hand. Or I want an algorithm to do it for me. How am I going to do that? How I can break it apart? How I can say that okay, this is your. How can it find my, for example, family network? All my family will be a different color. I want all my different social lives, friends from the school, friends from the where am I living, and my family, friends from the karate club, friends from my dancing club. How it's going to happen? So that's one of the important questions. And how I'm going to do that? There are different ways of doing it. And one very obvious thing to do, of course, is you will also agree with me probably. It's very easy. What you do is that you break the link with the highest witness centrality, remove it, and see if it is broken apart. Okay, let's do that. Because we can do it. If we can do it, we shall do it. Okay? So it is. So now what we do, we look at it. Is it now 2 parts? No, it isn't. So now again, we can do the same. But not now. Not immediately. I mean, we can look at the second highest witness centrality and remove it. But before doing it immediately, we have to do one more thing. I mean, I did this. I removed the highest one. All right? I removed it. It is now not 2 parts now yet. I want to be able to break it apart and see, how many groups will come out. But not immediately. I shouldn't be going, all right, then what is the next highest one? All right, this one, remove this. No, I shouldn't be doing that. I have to do something before that.
Yeah,
There are
but
4 of them.
is it the only reason?
No.
Said is saying.
No. I mean, it's more a general
Yeah.
question. It is
There
not
should be,
because
there
this is
should be
4.
another reason why we shall not do it. that way.
Even if it was only one of them, I shouldn't have done that.
Why?
Ask the question maybe.
Okay, I asked the question again. Tricky question. Very tricky. Yeah, it is. So, I said which one of the edges has the highest edge number will be removed. I removed it. It is not yet 2 parts. So I have to continue removing edges, right? So what I say, I shouldn't be going here and find the next highest one and remove it. I shouldn't do that.
Because the highest 6 is most natural.
Very good. Now, no, you mean, but then you're saying
But
that when you break
Five,
it,
six, six,
You
the
mean 5 and
units
6?
must be redistributed, right?
Mhm.
This is what you're saying.
This is 21
Yeah.
and this is 10.
Actually, not.
But it is not the case.
Exactly.
Yes?
Very good. Perfect.
It's not the case. I mean, it is not true.
Why? Because the network changed, right?
Yeah, the network changed. We changed the network by removing the edge.
Exactly. This is exactly. You all got it right. Perfect.
So,
This is really important.
so what I have to do now, again, I have to analyze the network again. Analyze network. Okay. So, you see, it's changed. So now I repeat. So then, as you would understand, it will break.
Then, for instance, if we are putting balls, which phosphorus in repair,
Yeah.
then we need to redistribute the network because that thing is really tangled now. Then we need to understand which rows are going to be used mostly, and then we should take care of it accordingly.
Yeah. So
Otherwise, we would only care about, for instance, 3-5 link, but now you're saying not the 3-5 link is important. But this is trivial, but there are obviously non-trivial cases. However, I have one more question.
okay.
You're saying now that since it is the probability, you say the 5-7 link has the highest probability, so you broke that link and redistribute. But then you're saying that probabilities are independent. So the ranks are not correlated because you reconstruct the thing, and then in the reconstruction procedure and before reconstruction, the importance of those things are not correlated. We can
Before
do
and
it.
after.
Yeah, before and after. So you're saying that this is rank independent way of doing the things, and you're also not sure about it. So there's an assumption.
I have to think about that. That's okay.
Yeah.
Very.
But is my question clear? Maybe we can discuss it later because
Yeah, it's
these
difficult.
are really nice things about discussing things with the probability. It's like probability A times probability B is a probability AB, but there is no intersection between probability A and B, so those are independent events that you're doing multiplication. So calculation of the between the centrality between the former network and the later network are independent. So there's an assumption of it.
Right.
But we all do those assumptions. No?
Yeah, of course.
But
But
Nate
it
Silver
is very
doesn't.
simple.
Nate Silver doesn't.
Yeah, so I will stop you again. And go back to my, no, not this one. Ah, this one. So, like, if I go on, this is again the same book, same chapter, page 74 and onwards. You see, by step, I see, then I'm really partitioning them up. I understand what are the parts of this network. When it is small, I can do it manually, but when it is not small, I have to do it with a algorithm. And the algorithm, okay, now as you see that it is finished. The algorithm that we talked about this algorithm before, but I just want to make you remember that. So I want to do this. I have to be able to do this with an algorithm because it all, why we are here. It wouldn't be interesting at all if there wasn't any computers around. Because we're talking about nodes of millions, for example. Like you will be having databases and your nodes and links will be stored in databases, and you should be making these calculations with an algorithm. You cannot do it by hand. So what I need to know, what I need to find, of course, the first step is the shortest path. I'm giving you two nodes. So you remember that for all this to be calculated, I needed to have all the pairs, all the possible pairs of nodes in my network and calculate the paths in between. So how do we do that? Just to remind you that we had this source and target. Okay? We had this source S, and there's a target T, and we want to go from S to T. What is the shortest path? What is it? S, A, D, and T. Right? That is the shortest path. And there is only one of them. There are no two different shortest paths with equal distances. So what I do is this. First of all, I give -1 an attribute to all of the nodes. All right? And then my algorithm is going to start with the source. I give the algorithm source, and algorithm, when you give the algorithm one node that is now the source, it turns its attribute from -1 to 0. That means I looked at it. I looked at it. Just for you to remember, these -1s and 0s are just to computer to know, to remember if it looked at it before or if this is a new network that never been looked at. And what I do is that I got the adjacent nodes of the node that I'm looking at. That is now S. And these are A and B. Now A and B turns to 0 because I am looking at them. I found them. And what I do, I put them in my queue. Alright? S, that is gone. But I put them in the queue. Queue means it's a stack. It's also another place that I want to remember that these people here in the queue, I will do an operation with them. Okay? So what I do, let me repeat this again. So algorithm is doing this thing. The reason that I want to repeat is that I missed one step for the S itself. So what I have to do, take this node, I'm going to go from S to T, and I'm giving the computer S and T, and this network. I give S and T and the network. And I say, you will go from S to T. What the computer is doing, taking S and put it into the queue. There is this queue, I don't know if it's not really visible, but it says queue here, and there's an S. It is a stack, you know, that I put things like a box. It's a box, it's a bucket. I'm putting it into the box. I put it on S, I put the S. So the algorithm says, you know, first of all, everyone is -1, and whatever I put in S, I turn it to 0. I turn this one to 0. This is in my bucket. And then the next step, this is 0 now. Find the adjacent nodes of S, of your point of interest. My point of interest, the node that I'm making the calculation is this. And put the adjacent nodes of S into A and B, and that's A and B. Put them into the box as well. Put them into the box. Okay? Now this is finished. S is 0. Now remove S from it, you know, S is processed, so remove it from the box. I have only A and B in the box. And for each one, if there is something in the box, take one of them from the box and repeat the same thing. I'm taking one thing from the box and I'm repeating the same thing. But I will do 2 of them together.